we have the integral of 5 divided by x squared minus 4, and we want to use what's called partial fraction decomposition to find the integral right here. So first, we want to decompose this fraction right here. So to decompose this fraction, we have 5 divided by x squared minus 4, then this, and then we factor the bottom. X squared minus 4 is x plus 2 times x minus 2. And then we know from, we have a theorem that says that this can be decomposed into two fractions with some constant a dividing by the first factor, and then plus some constant b dividing by the second factor. So we need to figure out what a and b are, and that will give us the decomposition. So we have this is equal now, and then to figure out what a and b are, we can go ahead and combine these. And if you have two fractions, to combine them, we can just do cross multiplication. So this is to be a times x minus 2, a times the factor x minus 2, and then plus b times the factor x plus 2. And then dividing by the product of the two denominators. So dividing by x plus 2, and then x minus 2. And we can see that if we take the first part right here, and we divide it by the denominator, then what's left is a divided by x plus 2. And then if we take this part and divide it by the denominator, then what's left is b dividing by x minus 2. So again, if you have two fractions, we can combine them by do cross multiplication. A times x minus 2 plus b times x plus 2. And then dividing by the product of the two denominators. And so now we have, if we compare the left side and the right side, this denominator and this denominator are the same. And so that means the two numerators have to be the same. So this has to be a times x minus 2 plus b times x plus 2. And then to figure out what a and b are, just pick something that make this factor 0, and then pick something to x that will make this factor 0. And so if we put a 2 here, then we'll get 0. So first, because this equation is true for any x, and so we can let x be 2. If we let x be 2, then our equation becomes 5, and then a times 2 minus 2, and then plus b, and then 2 plus 2. So now this is 5, and then 2 minus 2 is 0, and so 0 times 8 is 0, and then what we have here is 4b. And so from here, dividing by 4, then we get b to be 5/4. So that's how we figure out what b is. And then similarly, to figure out what a is, pick something here that will make this factor 0. So we can let x be -2, because -2 plus 2 is 0. Then we have 5 equal a times -2 minus 2, and then plus b and -2 plus 2. -2 minus 2 is -4, so we get -4a, and then -2 plus 2 is 0. So we get 5 equal to -4a, and so this, and then divide both sides by -4, then we get -5/4 is equal to a. And so if we go back to our expression right here, and then in the place of a, we have -5/4, and in the place of b, we have 5/4. And so if we add these two expressions together, then we get 5 dividing by x squared minus 4. And so the integral of 5 dividing by x squared minus 4 dx will be the integral of this and dx. And then we can separate these two parts right here. So that becomes the integral -5/4 divided by x plus 2 dx, and then plus the integral of 5/4 x minus 2 dx. And then we can move this constant of -5/4, move it to the front. And same thing over here, so we can move the 5/4. And then recorded, we have a formula involving this type of integral. If we have 1 divided by x plus some constant a dx, recorded this is the ln, or the natural log, of x plus a dx plus c. And so right here we have -5/4, and then this is the integral of 1 divided by x plus 2, so the ln, or natural log, of x plus 2. and this will be 5/4, and then times the natural log of x minus 2, and then plus c. And this is the answer.